All right, friends, it's your boy, Mr. Shackney, coming at you with another video. Today we're going to be looking at interpreting points on a coordinate plane. And so we're going to be plotting points, and we're going to interpret what those points mean in the context of the question. So the first activity, called unlabeled points, label each point on the coordinate plane with the appropriate letter and ordered pair. Down here you have some ordered pairs. You have A, B, C, and D. We want to make sure that they are plotted. So you have 4 dots, and you want to make sure that you plot them correctly. So I'm going to find A first. I'm going to go over to positive 7. 1, 2, 3, 4, 5, 6, 7. And I'm going to go down 5.5. 1, 2, 3, 4, 5. That's 5.5. This is A. B, negative 8. So I'm going to start at the origin and go negative 8. And then I'm going to go up 4. 1, 2, 3, 4. This is B. And then I'm going to go C. C is positive 3, and then positive 2. That's C. And D. D is negative 3.5, and then up 2/10. So that is about D right there. And so with this activity, we're hoping that you understand how to label points on the coordinate plane and graph correctly. So we always start at the origin, and then if it's positive x, we move this way. If it's negative x, we move this way. If it's positive, and then once we go our x direction, then we move our y direction. We either move up or we move down. Depending on if the number is positive, we move up, and if the number is down, we move negative. This comes from the fact that when we first started talking about number lines, right, we talked about anything to the right of x is positive and anything to the left of x is negative. Well, and then we also talked about the context of elevation. So anything above sea level is positive, and anything below sea level is negative. So that's for that activity. The next activity we're going to look at today is we're going to look at a thing called a graph, and it's going to be called account balance. So this is someone that has a bank account balance, and we're going to be examining it and answering some questions. So it says the graph shows the balance in a bank account over a period of 14 days. The axis labeled B represents account balance in dollars. So I'm going to look for B. B is right here. So this represents the balance that this person has. And then the axis labeled D represents the day. So these numbers represent day. This represents the amount of money in the banking account. So it says estimate the greatest account balance. On which day did it occur? So I'm looking for the highest point on the graph, right? So I'm looking for the highest point. This looks to be the highest point. To me, it's between 350 and 400. The greatest account balance is 375. Right, because 375 falls between 350 and 400, and on the day that occurred, it's day 14, because that tells me right there what day it is, and then I look over here to determine the actual amount or the estimate. And number 2 says estimate the least account balance, so looking for the smallest balance that was in the bank, and on which day did that occur? Well, if I'm looking at the graph, the lowest point seems to be here, and that's day 11. And if I go over, right, if I go over this way, it's pretty close to negative 100. It's not halfway. I would say maybe like that's negative 90, negative $90 in the account balance. And so you can have a negative balance. That's when you pay for things that you don't have money to pay for, and it's on that little card that we think, money just grows on. That's not necessarily true. You have to, have money in your account for that to actually work. And so 3 says, what does the point 6, negative 50 tell you about the account balance? Well, if you're looking at the axis here, remember that D really represents our X value, right? So 6 tells us on day 6, the account balance, so the account balance would be Y, so this is really your Y over here. The account balance was negative $50. And this occurs, right, because people, spend money that they don't have. And so when that happens, banks usually charge you a nice little interest, like not even interest rate, but they charge you a fee. This has happened to me before. The fee is like $32. And this was when I was, first learning to work and learn the ways of the world. So basically that's how you can have a negative bank account balance. And then how can we interpret the absolute value of negative 50 in the context of this problem? So remember that the absolute value of negative 50 equals 50, and that means that $50 is the amount of money the person owes the bank on day 6. Right? So that's what that context means. Remember that this means absolute value. It's not going to go away. And so from this activity, right, we really need to understand, how the coordinate plane can help us understand other contexts, such as bank account balances. This is a great way to document, right, how your bank account balance changes. And so this is a great way to see the change. So obviously a positive change would mean that more money has gone in. A negative change would mean that money is being taken out. So you're taking money out, you're putting money in. And if, so basically if it goes down, it's being subtracted. If it goes up, it's being added to your account. The last activity that we're going to look at today is we're going to look at high and low temperatures. So I've color-coded this for you so that you can see high temperatures would be red and low temperatures would be blue. So the coordinate plane shows the high and low temperatures in Nome, Alaska over a period of 8 days. The axis labeled T represents temperatures in degrees Fahrenheit. So I'm going to look for T. T is really, remember, my Y value, and the axis labeled D is really my X value, represents the day. So what was the warmest high temperature? Well, if I'm looking at this graph, I'm going to look for the dot that's at the warmest, right, the highest possible red dot, and that looks to be 28 degrees Fahrenheit. Then we're going to write an inequality to describe the high temperatures H over the 8-day period. So we, for this right here, we're going to say that H can equal 28 degrees Fahrenheit, or H is less than 28 degrees Fahrenheit, because the highest possible value we have is 28 degrees Fahrenheit. And so then we're going to look for the lowest low temperature, the coldest one. So we're going to look for the blue that's at the the lowest possible point. And so I see a blue dot right here, which is between -2 and -4. So to me, that looks like it's -3. So -3 degrees Fahrenheit. For this question here, what was the coldest low temperature? -3 degrees Fahrenheit. Write inequality. Remember that my inequality could be L is equal to -3 degrees Fahrenheit, or L is greater than -3. And so the reason like this is greater is because all the other cold points are greater than that point there. And so for this discussion, we're really focusing, well, we haven't even finished it, but we're really focusing on our inequality, being able to see the highest point. And then the next part is going to ask us to find the greatest possible distance. But I feel like I did not put that in there, which is my bad. So what was it called? Low temperature, write an inequality to describe the low temperatures over the 8-day period. And so I really want us to focus. There's one thing that I'm missing here that I need to add. So I want you to be able to look. These two dots, the red dot and the blue dot, are on the same vertical line, right? And when 2 points are on the same vertical line, your Y value is the only thing changing. And so I want to know the greatest possible difference between 2 points. And so I'm going to look for 2 points that have a pretty decent distance between them. So this one does right here. So I have 21 and I have 11 for 1. That seems pretty large to me. And that seems to be a 10, so that one right there, day 3, has a pretty great distance between them, day 3. And then day 6, I believe, is 17 and 7, that's also a 10-degree difference. So you really need to understand this concept of finding the distance between 2 points and know that the distance between them is always going to be a positive number, because distance refers to absolute value. And so when we're talking about distance, we're talking about that absolute value there. So that's what we're going to be looking at for 13 and 3 today, just getting through that. And then our next thing we have our exit ticket, which says you basically are given some data, and then you're given a blank coordinate, and then you're asked some questions. So for here, it says the temperature in Princeton was recorded at various times during the day. The times and temperatures are shown in the table. Label axis and plot points that represent the data. Well, for me, this represents my x and this represents my y. So looking at this, I know I'm going to need some negative values, right? So what I'm going to do, I'm going to draw my axis just like this, right? 0 in this context is going to represent midnight, right? Because if it's before midnight, it's going to be this way. If it's midnight, it's here. If it's after midnight, it's this direction. Temperature, right? Temperature is going to be represented with my y, and then this is my x, and that's going to be hours before midnight. So -5, 1, 2, 3, 4, 5, -5, and then 1 and 2/10. So -5. Now I'm going to count by ones, right? For this -1 and 2/10. So -1 and 2/10 probably going to be about there, right? That's the temperature. Temperature currently at that time. -2. So -2. So 5 hours before midnight, it's, pretty decent temperature. And then when it's 2 hours before midnight, so this is -2, and then I'm gonna go down 1 and 6/10. So the temperature got colder, right? And then at midnight, it's at -3.5. 3.5. So at midnight, it's super cold. And then 8, so after midnight, eight hours after midnight, it's at 1, 2, 3, 4, 5, 6, and that kind of falls off my coordinate plane there, and that's not intentional. But you can see that the temperature, right, is warmer here. That's kind of 5 hours before midnight. Still cold in the positive range. It's colder than it was, so it means that either a cold front's coming through or something's happening, right? So in the town of New Haven, the temperature at midnight was 1 and 2/10 degrees Celsius. Plot and label this point. Which time was warmer at midnight? So at midnight, right, remember midnight is my origin, it's 1 and 2/10. So that's a positive number, so that's going to be about there. And so this is New Haven, and this represents Princeton. And so it's asking which time was warmer at midnight. Well, New Haven was warmer. And then we were asked how many degrees warmer. Well, this vertical, right, so we're going to calculate the distance between these 2 points. So I have 1 and 2/10, and I have -3 and 5/10. What I'm going to do is I'm going to find the absolute value of both of these numbers. So 3 and 5/10, and 1 and 2/10. The distance is going to be, so this, remember, is 3.5 away from 0, and then I'm going to add 1 and 2/10 because that's also a distance from 0, so I should get 4 and 7/10, right? If I do the absolute value of that, it should be 4 and 7/10 degrees away from each other. So if you're talking about absolute value, remember that this point here is 3.5 from 0, and this is 1 and 2/10, and you add them together once you find their absolute values. And so if the point 3, -2.5 was also plotted on the diagram, what would it mean? Well, 3 hours before midnight, 3 hours after midnight, because it's not after midnight. Let me fix my thought there. After midnight, the temperature was -2.5 degrees. Right? So that's what we're doing today, interpreting points on the coordinate plane. I'm sorry for some of my Easter eggs. If you do find them, please let me know. And I hope to, if you like this video, click a quick subscribe, and I will see you all soon.